So welcome everyone and welcome to this lecture. I think this is lecture number 6 for thermodynamics. And in the previous lecture, we were dealing with the second law of thermodynamics. And we had solved some question on the Carnot cycle. We had seen what is heat pump. We had seen what is a heat engine. Do we remember this? Heat pump, heat engine. Heat pump takes heat from a colder body reservoir. Work is input. Heat is given out to a hot reservoir. In case of an heat engine, it is reverse. Energy is taken from a hot reservoir. Work is output, and then heat is given out. Okay, so that part is done. In today's class, we will try to finish remaining 2 or 3 things apart from heat transfer. There are 2 small topics remaining, and we will try to cover them up in today's class. So from where do we begin today's class? From today's class, we begin with a topic known as thermometry. Have you heard this topic, thermometry? Thermometry is the name of the topic. Have you heard about this? Yes or no? Yes, thermo means temperature. Whenever you use the term metry means the measurement. Calorimetry is the measurement of calories, which is the measurement of heat. Thermometry, therm is temperature, metry is measurement. So basically this entire thing simply means this branch deals with the measurement of temperature. Thermometry is a branch of physics which deals with the measurement of temperature. How the temperature is measured. I hope you have an idea about this. This is a very small topic, very short topic. We can expect one question to come from this topic. Either it will be one or it will be none. Measurement of temperature is what we are going to deal with. Now, before going on to measurement of temperature, we must recollect what do you mean by temperature? What do you mean by temperature of a body? What do you mean by temperature of a body? I hope I have told you the definition of temperature. Yes or no? What do you mean by temperature of a body? I have told you that, right? It is a measure of the degree of hotness, how hot or how cold a body is. The measure of that degree of hotness or the degree of coldness is known as temperature. How hot or how cold a body is measured by its temperature. If the temperature is high, we call the body hot. If the temperature is low, we call the body cold. It's as simple as that. Do we understand this? What is the SI unit of temperature? The SI unit of temperature is Kelvin, and we have already seen Kelvin. Then there are other degrees of measuring temperature, namely degree Celsius, degree Fahrenheit, and so on. We will be discussing these degrees, degree Celsius, degree Fahrenheit, and how this temperature is measured. That will be dealt in this class. I hope you are noting this down. I'll give you a minute to note this down, please. Have you noted this down? Okay. Then I hope you can all see this. Temperature. What does temperature indicate? Just confirmation of what I have told you. It indicates the degree of hotness or the degree of coldness of a body. This is from your sheet. Now the question is, how do we measure temperature? How do we measure temperature? And the answer is very simple. We measure temperature using a thermometer. Thermometer is a device that helps us in measuring temperature. The next question would be, how does a thermometer measure temperature? How does a thermometer measure temperature? So now we will go into discussion of this thing. How does a thermometer measure temperature? Just to give you a brief outlook, every thermometer has a temperature scale. What do you mean by temperature scale? Temperature scale is nothing but in what unit you are measuring this temperature. This temperature scale could be in Kelvin, this temperature scale could be in degree Celsius, or this temperature scale could be in degree Fahrenheit. So basically to measure temperature, what do we need? We need a thermometer, which is going to measure the temperature. We need a temperature scale. On which scale or which unit are you going to measure the temperature? So the most important thing is, how do we know the temperature of a body? What is the criteria? How do we know how hot a body is or how cold a body is? To make a temperature scale or to make a temperature, we need certain substance. It should not be a substance. We need a certain thermometric property on the basis of which you can make this thermometer. Now, what is this thermometric property? We'll discuss these thermometric properties. I hope you have noted down these 3 points. We need 3 things to measure the temperature of any body: a thermometer, scale, and the third thing is the thermometric property. Have we noted this down, everyone? Okay. We have noted this down. Then we will start point by point on to each and every aspect of thermometry, what all we need, what all we require, and how do we measure, because this chapter or this topic is simply about all those things. So thermometry. What is thermometry? We have already discussed. This is a branch of physics relating to the measurement of temperature or the degree of hotness or the degree of coldness of a body. How do we measure temperature? That is the next question. Well, my dear friends, the answer is very simple. We measure temperature using a thermometer, which is an instrument which is used to measure the temperature of a body. There are some facts given over here. I don't think they are of much importance. The highest possible temperature is 10⁻⁸ Kelvin, which is fusion. I told you about fusion. Do you remember? Fusion, radioactivity. And I told you, fusion is the process which gives you a very clean energy. But again, fusion cannot happen on Earth because the temperature required for that fusion is very high. It only happens in the center of sun. Do we remember this? The lowest possible temperature that we have achieved is 10⁻⁻8 Kelvin. Production and measurement of very low temperatures is known as cryogenic. You must have heard about the term cryogenic engines. Have you heard about the term cryogenic engines? It may not be in your age, but in my age, there was a lot of fuzz about these cryogenic engines. Search Google and you will understand what is a cryogenic engine. Measurement of very high temperature is called pyrometry. pyrometry. So these are the two terms that you must understand. What is cryogenic? It is the measurement of very low temperatures. What is pyrometry? It is a measurement of very high temperatures. I'll give you a minute to note these two words down. Have you noted it down, bacha? Cryogenic and pyrometry are the two words that you had to note down. Done that? Kajal, how are you doing? Done that? Shall I move ahead? Am I visible? Am I audible? Yes. Pakka? Okay. Now, we talked about thermometer. Now, every thermometer has a scale, temperature scale. We'll talk about these thermometers. We'll talk about the temperature scales. But every thermometer is based on some property. This property changes with temperature, and such property is known as thermometric properties. Please note this down. This is not in your sheet. Thermometric property. It is the property of any substance which changes with temperature. If some property changes with temperature, that property is known as a thermometric property. Do we understand this? Do we understand this? This is the property of a substance that changes with temperature. Now let us think about what all things change with temperature, and let us take two or three examples of this. What changes with temperature? Now can you think about some things? Anything that changes with temperature? You can think about those things. We can use that property to make a thermometer. When you think about anything that you see in your daily life that changes with temperature, the first thing that I can think about that changes with temperature is the volume of a liquid. Have you seen this changing with temperature? Volume of a liquid, does it change with temperature? Yes or no? Have you seen milk boiling? When it starts to boil, the volume increases tremendously. Yes or no? If temperature increases, then we see that the volume also increases and vice versa. Yes or no? Are you there with me? Kajal, are you there? See, I remember your name now. I sometimes get short-term memory loss, but then I recollect it. If the temperature increases, volume of a liquid increases. So we can use this property. We can use this property in making a thermometer. What all things do you understand? Changes when you change temperature, pressure of a gas at constant volume. If I keep the constant volume and I increase the temperature, remember pressure is directly proportional to temperature. PV is equal to nRT. Please raise your hand if you understand this. No one understands this? Everyone is sleeping in the class? You only sleep in your rooms, on your bed, and you only need 4 to 5 hours of sleep. If you're sleeping in class, well, my dear friends, you will sleep. You will probably not get any time to sleep in your entire life because you will not be getting any jobs. When you sleep in the class, probably you can become an MBA chai wala, but MBA chai wala has already been taken away. So you will have to find new professions for yourselves. You can become a YouTuber by sleeping in the class, but there are enough YouTubers now. So even that thing is taken away from you. So I would suggest that if you want to sleep, you sleep in the hostels, not in the class. What happens if you increase temperature? Please note it down. When temperature is increased, what happens to pressure? Pressure also increases. P is directly proportional to D. Yes or no? Arey, tell me yes or no. Similarly, I can say volume of a gas at constant pressure. Are we getting my point? Volume is directly proportional to temperature. Yes or no? Do we understand this? That means if I increase the temperature, the volume of the gas or the volume of the liquid, any substance, the volume changes. It's only water that has anomalous expansion from 0 to 4 degrees Celsius. If you increase the temperature of water, the volume does not increase, the volume decreases. Do we remember this? From 0 to 4 degrees Celsius. The last but not the least is resistance of a wire. Resistance of a conductor or a wire. Resistance. Resistance to flow, opposition to flow of current is known as electric resistance. Resistance of a wire changes with temperature. If I increase the temperature, the resistance of the wire increases or the conductivity decreases. Do we understand this? Can I have some raised hands? And therefore, since there are 4 properties or 5 properties, I'm only telling you 4, this is more than enough for your course. You can have different types of thermometers that are based on these 4 properties. The first one will be known as liquid thermometer. The first one will be known as liquid thermometer because it is based on a liquid. The yellow one will be known as liquid thermometer based on a liquid. The green ones will be known as gaseous or gas thermometers because they are based on gas. Number two will be known as, please remember the name, I am not writing it, you will have to remember it. Number two is known as constant volume gas thermometer. Number two is known as constant volume gas thermometer. Number three will be known as constant pressure gas thermometer. Do we understand this? Or everything has gone above our heads? The last one, the pink one, is known as the resistance thermometer. Thermometer which is based on resistance. Do we understand this? Raise hands will give me more confidence that we understand this. I'll give you a minute to note this down because there are still more things that are coming up. Have you noted this down, bacha? Yes. Then comes, now we have the ingredients to make a thermometer. We know a thermometer is a device that measures temperature. We have thermometer. We have a thermometric property that can be used to measure, no, to make this thermometer. What we all need now is a scale or a unit, yes or no? So the next heading is temperature scales, and what are the scales that we have? We have different scales. We will come to those scales in the next slide. Every scale that we hear about normally has two fixed points. One is known as the lower fixed point, LFP, and the other one is known as the upper fixed point, UFP, the lower point and the upper point. And what are these lower points and upper points? The lower point is the melting of ice, which is 0 degrees Celsius. The upper point is boiling of water, which on Celsius scale is taken as 100 degrees Celsius. So every scale that we talk about has got two fixed points. Now, what do these fixed points do? I'll tell you in a while. Right now, you will note this down. Every scale has two fixed points, the lower fixed point and the upper fixed point. The lower fixed point is the freezing point of water or the melting point of ice. The upper fixed point is the boiling point of water. I'll give you a minute to note it down. Have you noted this down? Okay. Now you have two fixed points, and there comes the different scales. The ice point or the lower fixed point, and the steam point or the upper fixed point. And then you have third thing, which is known as the number of divisions. How many divisions are there? So what do we do here? In order to make a scale, for example, the Celsius scale, we have given randomly one value to the lower fixed point. We have called the lower fixed point or the ice point the temperature at which ice melts at 0. So it becomes 0 degrees Celsius, and we arbitrarily call the boiling point of water. Mr. Celsius told us that the melting point of ice is taken as 0 and the boiling point of water is taken as 100. Between 0 and 100, they make 100 divisions. Between 0 and 100, they make 100 division, so that one division becomes equal to 1 degree Celsius. And this is how the Celsius or the centigrade scale is made. To make any scale, we need two fixed points and we give it random values. For example, I can make a scale of my own, and I will just illustrate how will I make a scale of my own. Here, I will just make a scale of my own and I will just call it Aastik scale. Now it's up to Aastik sir how I want to make that scale. For example, I can call the ice point any random number and I will call it 5026. 5026 Aastik. 5026 degree Aastik. Now you will ask me, why is there 5026? 5026 happens to be my roll number. And that is why this is an important number for me. So I just call the ice point as 5026 degree Aastik. And then I think, what should I call the steam point? And I don't understand any number. I just call it, since this is 5026, I will call it 6026. 6026 degree Aastik. And then between 5026 and 6026, I will make 100. Nahi, I will make 1000 divisions. 1000 divisions I will make. So one division becomes equal to 1 degree Aastik, and that becomes my scale. Do we understand this? This is how randomly you can make any scale. I made a scale of my own. You can make a scale in your name. Fahrenheit made a scale in his name. He called the ice point as 32. He called the boiling point as 212 when he made 180 division. Rumor called it 0 and 80, made 100, made 80 divisions. Kelvin scale. Now, Kelvin scale is a somewhat different. Remember, important point, Kelvin scale is somewhat different. Kelvin scale does not have two fixed points. Kelvin scale only has one fixed point, and I will tell you about those fixed points just now after some time. But on Kelvin scale, the ice point of water or the melting point of water is 273.15. This is not given correctly here. You just correct it. 273.15 Kelvin is the ice point, and 373.15 Kelvin is the boiling point. In between those 2 points, we have 100 Kelvin divisions. So one division becomes 1 Kelvin. Do we understand this? Yes or no? Then we have the Rankine scale. The Rankine scale, the lower fixed point is 460 Rankine. The upper fixed point is 672 Rankine. So we have 212 divisions in between them. Then I have the Aastik scale. Aastik scale has 5026 Aastik as the lower fixed point, 6026 Aastik as the upper fixed point, and in between them, Aastik sir has created 1000 divisions. So one division becomes equal to 1 degree Aastik. Do we understand this? I'll give you a minute to note this down. You may not know all of this, but if you can remember all of this, you can remember all of this. All the question on the temperature scale will be coming to you from this particular table. Have you noted this down? I'll give you a minute to note it down. Have you noted this down? Okay. Now we come to the most important aspect of this chapter. And this is the concept that we are talking about. You make any scale that you wish to. As I told you, I made my own scale. Now, whatever you make, this relation must be true for all the given scales. What is the relation that I am talking about? The reading of that scale, whatever reading I get on that scale, minus the lower fixed point, which is the ice point on that scale, divided by upper fixed point, which is nothing but the boiling point on that scale, subtracted by the lower fixed point. This must be a constant for any scale that I, we, or anyone creates. What does that mean? If I have any temperature in degree Celsius, that temperature in degree Celsius minus 0, which is the ice point of degree Celsius scale, divided by the upper point, which is the boiling point of water on degree Celsius scale, minus the lower fixed point or the ice point on the degree Celsius scale. This must be a constant, whether it is degree scale or Rankine scale or Reaumur scale or Kelvin scale or Fahrenheit scale or Aastik scale. Do we understand this? Okay. Why has the camera turned all of a sudden? Did the camera turn or my eyes turned? Anyways, so for Celsius scale, this is the formula. For Fahrenheit, it becomes degree F minus 32 divided by 212 minus 32. For Reaumur scale, it becomes R minus 0 divided by 80 minus 0. For Kelvin, it becomes K minus 273 divided by 373 minus 273. For Rankine, it becomes Rankine minus 260 divided by 672 minus 460. Sorry. You simplify them. This is the formula that you get for all the scales, and using this formula, you can convert any temperature onto one scale, from one scale to the other scale. This is a shortcut of the same formula. We have just divided by 20 or 40 or 60 or 80, and we got this formula. Here we have divided by 20. Do we understand this? How we got this formula, the shortcut formula? The shortcut formula comes from the long cut formula, and the long cut formula is mentioned. Then we have this formula coming, and you must remember this formula because this is the only formula that comes in this chapter. And with this formula, you should be able to convert any temperature from one scale onto the other temperature onto the other scale. I'll give you a minute to note this formula down. Note it down in all possible variants so that it helps you. Have you noted this down, beta? Okay. Now, here are some important points that you must note and remember. A question can come based on simply this. And what are the important points? For a pair of temperature scales, if number of divisions are same, for example, Celsius and Kelvin, but their 0 point, freezing point and boiling point are different, they cannot show the same reading for any temperature. Celsius and Kelvin, they have the same number of divisions. It is not possible for them to show the same reading because their zeros are different. Using the above formula, the temperature on any scale can be converted into other scale. We have already seen that. This is one important formula. Any unit change of 1 degree Celsius is same as 1 Kelvin. Change of 1 degree Fahrenheit is 9 by 5 of degree Celsius. 1 degree Celsius is 5 by 9 times of Fahrenheit scale. Do we understand this? These are shortcut formulas. I will give you a minute to note this down. Please note it down, bacha. Have you noted it down, bacha? Shall we move ahead? Okay. Then comes, remember that the number of questions in this is very less. So I'll just show you one or two. This is the first question that comes. And let us see who gives me the answer for this one. The correct value of temperature of 0 degrees Celsius on the Kelvin scale is how much? And the answer is A, 273.15 Kelvin. Again, as I told you, it is simply based on your knowledge. If you know it, you know it. If you don't know it, You don't know it. Okay, do we get this? Okay, then again, this is one question that has come multiple times, and please remember this. I'll tell you also how to solve this, but you will have to probably remember its value. At what temperature does the temperature in Celsius and Fahrenheit scale equalize? At what temperature both the Celsius and the Fahrenheit scale equalize? I'll give you a minute to calculate it. So, do we have the answer? Yes, the answer is 1. And when I say 1, it is minus 40 degrees Celsius and minus 40 degree Fahrenheit. And how do we do this? Well, I'll just show you a glimpse of what we have already done, and we have already seen this formula. Yes or no? C by 5 is equal to F minus 32 by 5. Both the readings have to be same, so I call it X. So X by 5 should be equal to X minus 32 by 9. You just calculate the value of X from here and you will get your answer. And I think the value of X that will come is minus 40. And you remember this, at minus 40 degree Celsius and degree Fahrenheit become equal. Will you remember this for me? Please raise your hands and let me know. Can you remember this for me? Yes, no, no, yes. I'll give you a minute to note this down. Can we move ahead? Okay. Then here comes the next question. And again, it all depends on how much you can recollect. Minus 40 degrees Celsius is equal to the following temperature. And again, the answer is as simple as minus 40 degree Fahrenheit. Yes, that is correct. So, as you can see, the formulas are very simple. The questions are pretty simple. And if you remember them, the same questions will be coming in the examination hall. Now, we move on to the last part of this topic, and those are the different types of thermometer. I have seen 1 or 2 questions come from this, and therefore I will give you the formulas for different type of thermometer. on different type of scale. The first thermometer is known as the liquid thermometer. Do we understand what do you mean by the liquid thermometer? This liquid thermometer is based on which thermodynamic property? It is based on the expansion of liquid. Do we understand this? These liquid thermometers are based on the basic principle of expansion of liquid. Do we understand this? Normally, we have two types of liquid thermometer. One liquid thermometer has mercury inside it, which is the one that you use, doctors use. The other one, which you might also use, is the alcohol thermometer. Don't drink the alcohol inside it because it is not drinkable. It is only used for medicinal use, of no use. Can't drink it. It's only put in a thermometer and it expands. So basically, what happens when the temperature increases, the liquid expands, the volume increases. When the temperature decreases, the liquid contracts and the volume decreases. Do we understand this? So basically what do you see is the length of the liquid column. This length of the liquid column, how high or how low it is, that decides the temperature. Do we understand this? Now how do we find the temperature on this degree Celsius scale? It is length at the given temperature minus length at 0 degrees Celsius divided by length at 100 degrees Celsius minus length at 0 degrees Celsius. This has to be multiplied by 100 to get the temperature on the Celsius scale. This is same as the formula that we have seen. This is same as the formula that we have already seen. The formula which says temperature on this scale minus the lower limit divided by upper limit minus lower limit, that is constant. You just multiply it by 100, you get the temperature on the Celsius scale. Do we understand this? How to remember this formula for temperature on the Celsius scale in a liquid thermometer? Can I have some raised hands? Girls have raised hand, boys are still looking here and there. Okay, if this is the formula for temperature on the Celsius scale, what will be the formula for temperature on the Fahrenheit scale? These are the two scales that will come to you. I have written the formula in red for temperature on the Celsius scale. Can you write the formula for temperature on the Fahrenheit scale? I will give you a minute. If you can write this formula, that means you have understood the different scales. I'll give you a minute to write down your formula. After a minute, I will tell you the actual formula. Have you noted it down, bacha? Have you written the formula for the Fahrenheit scale? And this is the formula for Fahrenheit scale. You may not get a question on this, but you can definitely get the formula and you will have to tell which formula is correct. So the temperature on the Fahrenheit scale ka formula would be simple. Temperature on degree F, Fahrenheit scale will be length at temperature T, whatever temperature is that, minus length at 32. 32 is the freezing point, divided by length at 212 boiling point minus length at freezing point 32, and this entire thing has to be multiplied by 180. Do we understand this? Did we get this formula? Yes or no? How many of you got this formula? Well, one girl, one boy. What about the rest? Well, even if you don't understand this, please remember this, because you still have time to redeem yourself, because the next type of thermometer is coming to you. The next type of thermometer is coming to you. The next type of thermometer is coming to you. And this thermometer is known as, I've already told you the name of this thermometer. This thermometer is known as, there are two types of these thermometer. One is known as constant volume gas thermometer. The other one is known as constant pressure gas thermometer. And this one that you see on your screens right now is known as what? It is known as the constant pressure, constant volume gas thermometer, because this is based on constant volume. Pressure is directly proportional to temperature. Do we understand this? Yes or no? Can I have some raise hands? And this one that you see here is the formula for temperature on the degree Celsius scale. Do we understand this? Yes or no? Please raise your hand so that I know that you understand that this is the formula for a constant volume gas thermometer on the Celsius scale. Can I have some raised hand that we understand this? Now, I'll give you a minute to write down the formula for temperature on the Fahrenheit scale for this thermometer. Remember, these thermometers are more sensitive and more accurate. Remember these 2 points, very important point. Gas thermometers are more accurate, more sensitive, better than liquid thermometers. I'll give you a minute to note down, to write down the formula for the Fahrenheit scale. A minute, 2 minutes. Have we noted down the formula for the Fahrenheit scale? Yes or no? Well, the formula for Fahrenheit scale. Yes, well done, my dear friends. I'm very happy for you. The formula for Fahrenheit scale, remember this formula. Question may not come because it is too complicated to calculate maybe, but the formula will definitely come. If it comes, you will be the one who will be knowing this formula for the Fahrenheit scale. And here comes the formula for Fahrenheit scale. Temperature on that scale minus length at, oh, why I'm writing length? Pressure on that scale minus pressure at 32 degrees Celsius. No, 32 degrees Fahrenheit. divided by pressure at 212 minus pressure at 32 multiplied by 180. This will give us the temperature on the Fahrenheit scale. Do we understand this? If you understand this, well done, my dear friends. This is a great job. Now, if I ask you, now remember, remember, Kelvin scale is not a liquid scale. Kelvin scale is not a liquid scale. So you don't have the formula for Kelvin scale in the liquid scale. Now I'll give you another chance to write the formula on the Kelvin scale for this gas thermometer. To write the formula for Kelvin scale on this gas thermometer, and I would be very, very happy if you can tell me the formula for the Kelvin scale. And I'll give you a minute to win it. A minute to win it. A minute to maybe write the formula for temperature on the Kelvin scale in the gas thermometer. Remember, there is no formula in the liquid thermometer for the Kelvin scale. A minute to win it. So, have you written the formula for temperature on the Kelvin scale? Yes. And how does the formula look like? Well, it is very simple to write. What is there? I will write it. The formula looking like for the temperature on the Kelvin scale. The formula look like this. Let me have the blue ink. Yes, I have the blue ink. Temperature on the Kelvin scale would be equal to pressure on the Kelvin scale, PT, minus pressure at 273.15 divided by pressure at 273.15 minus pressure at 373.15 minus pressure at 273.15 multiplied by 100. Do we understand this? Can I have some reason that we have written this formula? Yes or no? Yes, my dear friends, and you would be very surprised to know that this formula is wrong. And that is why you must remember the right formula. Now remember, I told you that the Kelvin scale is somewhat different than these scales that we are discussing. Kelvin scale, and remember about the Kelvin scale, very important point about the Kelvin scale, only for the Kelvin scale, only for the Kelvin scale, only for the Kelvin scale. Kelvin scale only has two fixed points. In fact, it only has one fixed point. For Kelvin scale, the fixed points are For the Kelvin scale, the fixed points are 0 Kelvin. Now 0 Kelvin is a temperature that cannot be attained. Is an absolute zero of temperature. This absolute zero of temperature, what happens, we don't know because we have not seen the absolute zero of temperature. So for the Kelvin scale, one temperature is 0 Kelvin. 0 Kelvin, everything vanishes. And what happens, we don't know. The other fixed temperature is the triple point of water. Triple point of water. Do we remember this triple point of water? It came into discussion in the previous class. Now this triple point of water is having the temperature of 0.01 degrees Celsius. This triple point has a temperature of 0.01 degrees Celsius. On Kelvin scale, it is written as 273.16 Kelvin. Will you understand this? Will you remember this? Kelvin scale has two fixed points. In fact, it only has one fixed point. The other fixed point is always 0. 0 Kelvin, what happens, we don't know. The formula for constant volume gas thermometer, constant volume gas thermometer for the Kelvin scale is somewhat different. And this is the formula for the Kelvin scale. Temperature on the Kelvin scale is pressure on that temperature divided by pressure at triple point of water. How much pressure was there at triple point of water, which is the fixed point. The other point is 0. So it is multiplied by 273.16 Kelvin. This is the formula for temperature on the Kelvin scale. Please remember this, my dear friends. Please remember this formula. Don't get bamboozled by the other formulas. This is the formula for temperature on the Kelvin scale. And this formula exists only for gas thermometers. Do we understand this? Pressure at the temperature T divided by pressure at triple point of water, which is 273.16 Kelvin, multiplied by 273.16 Kelvin. That gives you the temperature on the Kelvin scale. Don't forget it ever. I'll give you a minute to note it down. Have you noted it down, bacha? Yes or no? No or yes? Then we come to the third type of thermometer, and this is known as the resistance thermometer. What it is based on? Based on the resistance of metal or conductors. It changes with temperature. It is directly proportional to the temperature, my bacha. Platinum is used. Platinum is the metal that is used because it has high melting point and the variation of resistance is uniform. Please note this down. Very important point. Why platinum is used? Two reasons why platinum is used in resistance thermometers. One, it has high melting point. It does not melt. At high temperature, it also does not melt. it has a uniform range. The resistance changes uniformly from minus 200 to plus 400. This is the formula for degree Celsius. I will now ask you to write down the formula for degree Kelvin, degree Fahrenheit, degree Kelvin does not matter. They have given the formula in general. This is the formula for any scale in general. I only ask you to write Fahrenheit scale. You can write it on the Rankine scale. You can write it on the Reaumur scale. I hope you understand this. You have to write it on the Fahrenheit scale. I will give you 5 minutes to note this down. The platinum resistant thermometer works on the principle of Wheatstone bridge. Please remember this and write the formula for the Fahrenheit scale. I'll give you a minute to win it. Have you noted down the formula, bacha, for Fahrenheit scale? It will be resistance at T minus resistance at 32 divided by resistance at 212 minus resistance at 32. The entire thing multiplied by 180. Do we understand this? Yes or no? No or yes? Shall I move on to 1 or 2 questions based on this? Yes or no? And this is the question that you are going to attempt. Remember, it's not in your sheet. Let's see who can do this. The readings of a thermometer at 0 degrees Celsius and 100 degrees Celsius are 50 and 150, 50 and 75 centimeter of mercury. Find the temperature at which the reading is 80 centimeters. So basically they are asking you, they are telling you that right now the reading is 80 centimeters. Tell me what is the temperature. Can you do this for me? Raise hands of all those students who feel that they can do this. No one is confident enough of doing it. No one is confident enough of doing it. No, 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 that cannot happen. No one is confident enough. Everything is given in the question. Every question tells you how it is going to be solved. The answer to every question is hidden in the question itself. If you understand this, you would be able to solve this. Think about it. I'll give you a minute. Has anyone got the answer for this one? You have not tried enough, bacha. Anyways, I'll give you a hint because I want you to solve this question. So I'll give you a hint, and the hint is very simple. What is the hint? As I told you, every question tells you how it is going to be solved. This question is also telling you how it is going to be solved. For example, it is telling you that at 0 degrees Celsius, the length is 50. So basically, this is the value of L0. Do we understand this? Length at 0 degrees Celsius. I am not seeing all the hands raised up. Okay, then what is it telling you? Let me think about the second thing that it is telling you. It is then telling you the length at 100 degrees Celsius is 75. So that is the value of L100. Do we understand this? And the last thing that is left, my dear friends, the pink one, my favorite color, is AT. What is this AT equal to? This is the length at T degrees Celsius. This 80 is the length at T degrees Celsius. From here, you have to calculate the value of T. Can you now do this for me on the Celsius scale? Can you now do this for me? L0 is given. L100 is given. Length at T degrees Celsius is given. Can you calculate the value of T from here? I'll give you a minute. I hope you have understood what I was babbling. Yes or no? No or yes? Yes, sir. No, sir. Better I go, sir. Have you understood it, sir? Or shall I repeat again? Length at 0 degrees Celsius is 50. Length at 100 degrees Celsius is 75. Length at T degrees Celsius, the unknown temperature is 80. You have to calculate that temperature. I'll give you a minute to win it. Do we have any answers? Yes, sir. No, sir. Shall I solve it then? Well, the solution is right here on your screens. I hope you understand it now. Basically, I had already given you the formula. Temperature at T degrees Celsius will be equal to L at T, length at T, minus L at 0, divided by L at 100, minus L at 0, multiplied by 100. Do we remember this formula? Yes or no? Well, you just put that formula, that's it. You just put that formula, that's it. You just put that formula and that's it. Can you do it for me now? Length at T degrees Celsius is 80. 80 minus length at 0 degrees Celsius is 50. Length at 100 degrees Celsius is 75 minus length at 0 degrees Celsius is 50. This has to be multiplied by 100 and you get your answer as 120 degrees Celsius. Do we understand this? Do we understand how this is done? Yes or no? No or yes? Anyone having any doubt? Girls, boys? Can I expect that you can do the next one that comes in line? Or will I have to do it again for you? I'm expecting some question of this type to be coming in your exam for this year, and that is why we are doing it, bacha. This is my gut feeling. Can I give you a question and I expect that you are going to solve it for me and for us and for everyone who is there in the class? Yes or no? Well, this is the question now. The language has changed a bit, but the concept remains same. Now the question reads like this. The upper means the boiling point and the lower means the freezing point of a faulty thermometer. They have made it a faulty now. Of a faulty thermometers are 5 degree and 105. So it has changed from 0 to 100. It has become 5 and 105. The thermometer reads 25 degrees Celsius. What is the actual temperature? What is the actual temperature? This question and the previous question and any other question are all based on the formulas that we have done. So this is another type of question that might come. Faulty thermometer. I hope you can do this. We already have done formulae. And again, I will give you a hint. Do you want a hint or you can do it on your own? Do you want a hint? So you can do this question in this way. This is the freezing point on the new thermometer. Forget it's faulty. It is new thermometer. This is the freezing point of the new thermometer. This is the boiling point of the new thermometer. New thermometer, new scale, Aastik scale, or anyone scale. This is the new temperature. What is the temperature on the Celsius scale? So that is the question now. Do you understand the language of the question, how I am putting it now? I have made a new thermometer. I have made a new scale. Freezing point is 5. Boiling point is 105. If the temperature is 25, what is the actual temperature? Do we understand the question now? So how do we do this question now? If I've understood the question in a different way, how I am going to solve this question? I have just understood in a different way. So how I'm going to solve this? Please note this down. So what do I do? On this new scale, the temperature is 25. Do we understand this? On this new scale, the temperature is 25. The freezing point is 5. So remember, temperature on any scale X minus freezing point divided by boiling point minus freezing point is a constant. Do we remember this formula? Yes or no? So the new temperature is 25. 25 minus freezing point is given as 5 divided by boiling point is given at 105 minus freezing point is given as 5. that must be constant. For the Celsius scale, that is equal to C minus 0 divided by 100 minus 0. Everything is based on the same formula. Do we understand this? Everything is just similar. We just need two formulae, and that two formulae solves all the questions that are possible. Do we understand this? So there are only two types of questions that are possible. One is changing from one scale to the other scale, which is done in this way, or you will be given length to change that length or change that resistance into temperature. These are the only two questions that can come, and you now know how to solve these two questions. Yes or no? No or yes? One question to redeem yourself. Again, every question that comes in this chapter is based on two formulae only. I hope you can do this one. So I'll give you two more questions so that you are ready for the exam based on these two questions, because I know that there cannot be any other question that can come from this particular topic. And here it comes. Please give me the answer for this one. Temperature of a patient is 40 degrees Celsius. So it's a question from your field only. What is the temperature on the Fahrenheit scale? I'll give you a minute to win it. Have you got the answer, my dear friends? Is the answer there with you? Yes or no? No or yes? I'll give you one more minute. Have you got the answer for this one, bacha? So the answer is pretty damn simple. The solution is pretty damn simple. Temperature is given on the Celsius scale. We need to convert it into Fahrenheit scale. F minus 32 divided by 180 should be equal to Celsius minus 0 divided by 100. Or you can use that for shortcut formula 5 by 9, 9 by 5 wala. From there you will get the value of the temperature on Fahrenheit scale as 104 degree Fahrenheit. Do we understand this? Did we get the answer? No one got the answer? Only one student? What about the others? You did not understand the question, beta? What is the problem? Tell me. The question was pretty damn simple. Temperature was given in degrees Celsius. It had to be converted into Fahrenheit. I've just used the formula of degrees Celsius and Fahrenheit. Do we understand this? I've just used the formula of degrees Celsius and Fahrenheit. Do we understand this? You don't understand this? You don't understand what we have done? No one understands what we have done? We have just used these formulas, beta. Do we understand this? What's wrong? You just use this formula. We don't remember the formula. Please say something. What is so tough in this question? You just had to put the formula. Do we understand this? We had to convert from Celsius to Fahrenheit. Is this so tough to understand, beta? Celsius mein the temperature was 40 degrees Celsius. We had to convert it into Fahrenheit. So we just use this formula. This first one, this one, this one, or this one. Both are same. Have you noted down this formula? Yes or no? Well, that's great. Let us now move on to the next question. And I hope, bacha, you can do this. I am having high hopes that you will not let me down. So here comes a question, and I hope you will be able to give me the answer very, very quickly. Questions are pretty simple. Answers are also simple. And this is a question that comes now. At what temperature is the Fahrenheit scale reading equal to twice of Celsius? 2 times of Celsius. 2 times of Celsius. At what temperature Fahrenheit scale is twice of Celsius? Can we do this? Can we do this? Please try. The temperature has to be twice of Celsius. Fahrenheit temperature has to be twice of Celsius. I'll give you 3 minutes to do this. Temperature in the Fahrenheit scale has to be twice the temperature of the Celsius scale. I'll give you 2 minutes. Have you got the answer, beta? Anyone? On the Fahrenheit scale, the temperature must be twice of the Celsius scale. Do we understand the question? Well, then here is the solution that you can see. This is the formula that we are going to use. F minus 32 divided by 180 is equal to C minus 100. C minus 0 divided by 100. Do we understand this formula? Yes or no? Girls, boys, do we understand this formula? Yes or no? On the Celsius scale, I have put X. If the temperature is X, on the Fahrenheit scale, it becomes twice of the Celsius, so it becomes 2x. Do we understand this? Temperature on the Celsius is X. Temperature on the Fahrenheit becomes 2x. Do we understand this? We just need to solve. I hope you know how to solve. 1, just cancel it. This will be 5. This will be 9. This 9 will go here. This 5 will go here. And you will have the value of x. And the value of x is coming as 160 degrees Celsius. So when the temperature is 160 degrees Celsius, it will become 320 degree Fahrenheit. Do we understand this, how this is done? Anyone was able to do this one? Please raise your hands and tell me that, sir, I was able to do this. No one was able to do this? Not a problem. Not a problem. Please note it down, beta. I'll give you a minute. Shall we move ahead in life? Yes or no? No or yes? Then this is the question that comes for your, and I'm waiting for your answer. The temperature of a substance rises by 27 degrees Celsius. What will be the rise in temperature on the Kelvin scale? On the Kelvin scale, how much this would be? I'm waiting for your answers, bacha. On the Kelvin scale, how much will be the rise of temperature? On the degree Celsius scale, the temperature has changed by 27 degrees Celsius, my dear friends. What is the rise on the Kelvin scale? And what is the answer? Answer is straightforward. What is the answer? A, B, C, D. And the answer is 27 degree Kelvin or 27 Kelvin. It is not degree Kelvin. It is simply Kelvin. 1 degree rise is same as 1 Kelvin rise. Remember, they are talking about the change in temperature. Do we understand this? Do we understand this? The temperature changes by 1 degree Celsius. It is same as 1 Kelvin because both have 100 divisions. 1 degree Celsius ka rise is same as 1 Kelvin ka rise. Do we understand this? Please note this down in your sheet. Please note this down right now. Note it down. Everyone, please note it down. I should see all of your hands moving. 1 degree Celsius ka rise is same as 1 Kelvin ka rise. Please note it down. The rise of change of 1 degree Celsius is same as the change of 1 Kelvin. So change of 27 degrees Celsius will be same as the change of 27 Kelvin. Do we understand this? Please raise your hands that you have written this. Everyone, have you written this? Okay, then this is the last question for today. I hope that you can tell me the answer for this. A temperature difference of 5 degrees Celsius on Celsius scale. I have already given you it in note. Still don't remember the notes. Corresponds to the following temperature difference in the Fahrenheit scale. For 1 degree Celsius ka change, 1 Kelvin ka change happens. For 5 degrees Celsius ka change, how much is the change in the Fahrenheit scale? I had pointed you out on the notes, beta, but I don't know where do you keep your mind in the class. Remember, when you come to the class, your body is not the only thing that comes into the class. Your mind and the soul should also be there. The mind should be there in the class, beta. Okay, so what is the answer for 59? 5 degrees Celsius ka change in temperature will correspond to how much change in temperature for the Fahrenheit scale? And the answer is, and the answer is, and the answer is, so here I am going to tell you the piece of the sheet where this was mentioned, and I had marked it. You can see it clearly marked. 1 degree change in temperature is same as 1 Kelvin. 1 degree Fahrenheit is same as 9 by 5 degrees Celsius. 1 degree Celsius is same as 5 by 9. Have you marked this in your sheet? Yes or no? If you have marked it in your sheet, then you will get the answer. 1 degree Celsius is same as 5 by 9 degree Fahrenheit. From this, you can tell me what is the answer for this one. 59 ka answer. You can tell me the answer for this one. And the answer would be 59 ka answer. You can tell me. And the answer would be 25 by 9. And that would be 2.8. That is the answer. Do we understand this? So the moral of the story is very simple. Everything that comes in this topic comes from two formulae. The first formula is how to change from one scale to other scale. Reading on any scale minus reading at 0 divided by upper point minus lower point is same. Then the other formula is how do you convert length or pressure or resistance into temperature. Length at any temperature minus length at 0 divided by length at 100 or length at boiling point minus length at 0 multiplied by 100. You will get the temperature at Celsius scale. To get the temperature in Fahrenheit scale, you replace everything by L at 32 and L at 212. Do we understand this? Can I have some reason that we have understood this? I've done almost all the questions that were possible that I think can come in the examination hall. You can go through this lecture once again. If you have any doubts, come back. Else the class is over for my end. Take care and have a nice day.